Good morning, class. So today we are continuing our talk on subnets and subnetting and subnet masks and all of that sort of stuff. So you're going to see my notes because I don't have a second screen anymore. So hope that's okay with you guys. So we've gone over how to go from a subnet mask 255.255.255.0 to binary, which would be 111.81.81.81.80s. And we've figured, and we know how to go from binary back into a subnet mask with decimal numbers. So what does a subnet actually do? It divides a network into a bunch of little networks. It subdivides a network, or it's a subset of a network. Subnet, haha. So it's a way to divvy up the network. If you don't have the same, for now, what I'm going to say is if you don't have the same IP address or the same subnet mask, you can't talk to another computer. For now, that's what I'm going to say. Once we're back in class, we're going to do some experiments to see if that's really true. But for now, we're just going to say if you don't have the same subnet mask, you can't talk. So one thing I didn't go over yesterday is an IP address has two parts. It has a network host, a network part, and a host part. So what does that mean? So basically it means that I don't have a pen, so I have to use my finger. So it's going to look really sloppy, so I apologize. 192.168. We'll go with 0 because I like that better. .o is IP address. This right here is our network, is the network portion, and this right here is the host. Oops, not host. Host. Now, typically at home, you guys will have something like this, either 192.168.0.0 or 10.0.0.0. And a subnet mask of 255.255.255.0. So this is your subnet mask. That's typically what you guys have. That's what you should. So this means that this is the network portion, and this is the host. Again, what this means, a little review from yesterday, because this 255 here, they're all 255s, that means that these three octets in the IP address won't change for anything on your network. The only thing that will change is this host part, which is why every IP address on your home network starts with the same three numbers. And then typically your router is 192.168.0.1. This is your router. And then your devices start at .2, .3, .4. Make sense? Okay, good. Let me jump back to my notes. So with our subnet mask, we borrow a portion of the bits in here to divvy it up. So I'm going to erase this. Now this 255.255.255.255 is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 0, 2, 3, 4, 5, 6, 7, 8. So this right here is that network, or is that subnet mask. So in order to create a subnet, what we do is we keep this as it is, and then we end up borrowing, we start borrowing these bits, and we'll actually divide it into something like this, whereas these three bits join the network portion here, and these 5 bits become part of the host. So notice if you have fewer bits if you only have 5 binary digits, you can only have 32 IP addresses because that's 2 to the 5th power, which is important. So for this, let's say we're going to borrow these 3 bits. We then do, I'm not going to rewrite all those ones, so this becomes .111. And then we have 0, 0, that's 6, 7, 8. Now this should look vaguely familiar to you guys. Not necessarily the specific number, but the fact that you now need to, what's the binary of this number? Or what's the decimal equivalent of this binary number? Well, that would be, you guys did this in your homework. It should be, do I have that sheet still up? I do not. Let me open it real quick for those of you who have forgotten. Here we go. So we're going to add, since it's the first three, we're going to add these three together, which equals 224, I think. Yeah. So this is a dot 224, right? Let me just, subnetting info, 128 plus 32 is 160. 160 plus 64 is 224, yeah. So this is a 224. So this subnet mask would be a 255.255.255.224. Woohoo! Now, how many subnets is in this? Is in what this subnet mask means. There's how many actual subnets. I want more pages. Oops. I just want it in. All right, hang on. Let me go back. Okay. So this is a 2.224 subnet mask. Now, how many subnets does that create? Well, we know, if you notice, not if you notice, but these 3 bits here are what we need to know. What we do is we do 2 to the number of bits borrowed equals the number of subnets created. Meaning 2 to the 3 equals 8, so we have 8 subnets. What does that mean? Well, that means we can have 8 distinct mini networks on our actual network. So let's say we're doing the school's network and we're using this subnet mask here. We're going to divide, pretend this is our entire school network. This is a very poorly drawn logical map. And what we're going to do is we're going to go cut it in half here. And let's say this is 203 lab. This is the library computers, right? I'm just making stuff up. This is the computer lab in 202. This is all of the stuff in the FAC, all the tech stuff. This is all stuff that students can access. Excuse me. Or what else? Let's say we have a gaming club, a computing game club, computer game club. So computer game club, and that's it. All right. Let's say we have these 3 things. We don't want to have an individual network for each one of these. We want them to be one network that everything in here can only talk to that, and then it goes to the router. Everything in here can only talk to itself until it goes to the router. If someone in the FAC wants to talk to someone in the gaming club, they have to go to the router, and then the router has to route the information here, and then it has to come back to the router, and then back to FAC. So this is what subnetting does. And the reason we went with a 2 to the 3, we went with 8 subnets, is because we have 5 areas that we want to split up our network into. If we went with a 196, so instead of there's a laser pen somewhere. Text highlight, nope. Highlighter, nope. there's a laser pen. I'm gonna add that. So, oh, that's really tiny. And I'll get rid of that one. There we go. So if this right here, this wouldn't be a .224, this would be a 196. So if that was a 196, that would mean we've borrowed 2 bits. So 2 to the 2 equals 4. We could only have 4 networks. We could not have our computer game club. So everything works in powers of 2. So we have our big network here. Our big network here. I want it 100%. Add. Get rid of that one. There we go. So yeah, this is our whole network. It has to be in powers of 2. Like in cutting up subnets, I can't have 6 subnets. It's 1, 2, 4, 8, 16, 32, 64, 128, or 250. I don't think you'd have 256. But that's how it has to be. You cannot have 6 subnets. You can have 5 that are being used and 3 that are unused. That's totally fine. But the number of subnets is always a power of 2. Okay. So hopefully I haven't lost you. How much time do we have? This is 11 minutes so far. Let me jump over to my notes. And okay. So here we go. This is my little cheat sheet. So if we borrow 0 bits, you have 1 big subnet. That's what you have at home. If you borrow 1 bit, you have 2 subnets. 2 bits, 4 subnets. 3 bits, 8. 4 bits, 16. 5 bits, 32. 6 bits, 64 subnets. 7 bits, 128 subnets. 8 bits, 256. This almost never happens. Notice the number of bits borrowed results in 2 to the n subnets, which we just went over. So if I have 8 subnets, like I say here, how many hosts can I have? Well, that's a very good question. Basically, all you do is you do 256 divided by the number of subnets created. So in this case, it would be 8. So 256 is 32. So we can have 32 hosts per subnet, which is pretty good. So 32, it's like, for this example, we have, let's say we have 20 computers here, we have 10 here, we have 10 here, we have 15 here, but we have 25 people in our gaming club. You have to take a look at all of the number of computers that are going to be in a subnet before you can create a subnet. So this is really important when you're designing a network to know what's going where, and it's always super important to future-proof by having spares. It's not a good idea to, okay, right now this is exactly what we need. When you're first designing a network, we've had to buy, Mr. Vishnoff just bought a 48 port switch instead of a 24 port, even though currently we only need like 20 or 22 ports, but because it'll save time and money and effort and everything if you buy the 48 port, because then you can just start plugging new things in, as opposed to, we don't have any room, now we got to go back, we got to order a whole nother switch, which is double the money, as opposed to $200 more. It's now $600 more in total. So it's just a good idea to think about the future and future-proofing your network. So hopefully I haven't lost you guys. Hopefully I've made this relatively simple. Again, you guys can ask me questions on campus. What we're going to do now, let me take a look at this. Okay. So in one subnet, if you only have one subnet, like you have here, when you borrow 0 bits, you have, so I'm going to get this. And so when we have bits borrowed is 0, number subnet is 1, number of hosts is always 256 minus 2 equals 254. I'm going to get to that in just a sec as to why. So if I have 1 bit borrowed, I have 2 subnets. I have 128 minus 2 is 126 numbers for a host. So if I borrow 2, that is 4. That is 64 minus 2 is 62. 3 is 8, and that's 32 minus 2 is 30. If I have 4, that is 4. That is 16 minus 2 is 14. 5. Then, oh wait, no, I screwed something up. Here's my eraser. 10, 2, 4. 16, yeah. And then this is 32. So then I have 8 minus 2 is 6. And I have 6, and that gives me to 64. And that gets me to 4 minus 2 is 2. 7 bits borrowed is 128. That gets me 2 minus 2 is 0 hosts per bit, and 8, that's 256. That gives me like 0 minus 2 is 0, like not usable. So you don't really use that too often. Now when I say number of hosts, that is not the number of IP addresses. This is a very tricky thing, and I will use it on quizzes, that there is a huge difference between the number of available IP addresses and the number of available hosts. The number of available hosts is always 2 less than the number of IP addresses. And the reason that is that the number of IP addresses is just the number of IP addresses in that subnet. The ones that you can use for a host are the ones that you can actually assign to a device. There are a couple IP addresses you cannot give away to a device, and that is the first IP address in a subnet and the last IP address in a subnet. So if we're going back to, let's go back to this example here where we have 32 hosts, and we're using a 192.168.0.0 Subnet Mask 255.255.255.224. So I've borrowed 3 bits, so let me scroll up here. So I have 32. So 192.168.0.0 is our network name, or network address actually. And the last IP in this subnet, there's 32 IPs in this subnet, and it starts at 0. So, we do 192.168.0.31. This is our broadcast address. How did I know it was 31? Well, again, there's 32 IPs per subnet. If there's 32 and 0 counts as 1, and then 2, 3, 4, 5, 6, 7, 8. Those of you who took programming, 0 to 10 or 0 to 9 is 10 numbers. 0 to 31 is 32 numbers. So this is our broadcast address. This network address is basically just how this subnet gets created. It has to have a basing. It has to have a base. It has to have a starting IP address. And if you assign a device to the starting IP address, it screws everything up. The last IP address to this broadcast address here, right here, this is the equivalent of going to Starbucks and someone yelling out your name, Jimmy, I got your drink. You going up and you taking the drink. That's the broadcast. That's where all of the devices on the subnet talk to each other. With just general, hey, who's got this? That's where ARP, the protocol ARP, is typically on the broadcast level, broadcast channel, broadcast IP. So you go to Starbucks, Jimmy, here's your drink, and you walk up and you grab it and you go, oh wait, and you start talking discreetly with just them. Then that changes, and then that goes to the switch, and it's all private and whatever. And you go, this was this made with almond milk, because I can't have regular milk, and they're like, oh, I forgot, and then they fix it, and then they yell out your name again, and then everyone knows they screwed up. So again, so the first IP address in a network is reserved, or in a subnet is reserved for the network address. The last IP address in a subnet is the broadcast address. Now the last thing I'm going to go over is if I have from zero all the way to 255, there's 256 IPs, or numbers, IPs. If you cut the network from 0 to 255 in half, that means you go to 127 and 128. So this is subnet 1. That should be 2. This is subnet 1. So this would be for a dot 128 network. Then if we go from 0 to 255 and we cut it into four subnets, which would be a dot 196, 192. So I'm going to cut this in half again. So this goes to 127 and 128, and then I have to cut that in half. This goes to 63 and 64. Again, there is 64 IPs in this one, 64 IP addresses in this one. Is that 192? Probably. And 191. 64, 64. If I do this again with a .224 all the way to 255, this is 8 subnets have been created. Now it's getting a little crowded. There's 4. There's 8. Each one of these has, let's scroll back up. So if we've created 8 subnets, that means we have 32 bits, or 32 IP addresses in each one, so that would be 32. So this would go from 0 to 31, and then 32 to 63, and then 64 to 95, and then 96, all the way to, 31, 127, and then 128. I'm not going to keep doing that because I feel like I'm boring you. But hopefully you understand that every time you borrow a bit, you have to cut the number. You cut the IP range of .250 of 0 to .255 in half. So last thing I'm going to do, because I feel 22 minutes. I'm going to go over a worksheet with you, and this is going to be your homework. I'm going to put a couple of these online. So for example, if we have the subnet, if we have the IP address 192.168.10.0 with 4 subnets, I'm going to walk you through how you do this. So if I have 4 subnets, that means how many bits do I need to borrow? Well, remember, draw with touch. Number of subnets equals 2 to the bits borrowed. So 2 to the x equals 4. 2 to the what? Well, that would be 2. So your answer there is 2. Eraser is 2. What's the total number of subnets? Because I've already giving you the subnet here, you can just put 4. What's the total number of usable hosts per subnet? So this is tricky. Usable hosts. That's not IP addresses. So what we do, remember, is we do 256 divided by 4 equals 64. Then we have to subtract 2, which gives us 62. Subnet mask. Oh, CIDR notation. I was going to go over that tomorrow. Okay, don't do this one for now. You'll go back and fix this. You'll go back and add this. What's your subnet mask? Well, if I've borrowed 2 bits, that means I have 2, 5, 5, 2, 5, 5, 2, 5, 5. And for now, all of our subnet masks are going to be 255.255.255. something, just for now. So if I borrowed 2 bits, that would mean in binary, this would be a 1, 1, 0, 0, 0, 5, 6, 7, 8 to go here. And and that is a 192. You think I'd memorize those by now. And then what you need to do, oops, scroll down, no. Subnet address, so what you would do is here, we would go, okay, for subnet 192.168.10.0, my host range is going to be 10.1 all the way to 10.63. And then I have 192.168.10.63. Okay, hang on, I screwed something up. So if it's 4 subnets, 64. So but 60. So this is 63. This is 62. So I hope I made this easy to understand. There's a ton of videos on YouTube. I'll post a link to a couple of them. If you have questions, please on campus me. You can look at previous videos of mine where I walk through this in class. I understand it's kind of difficult to do. You guys can't ask me live questions, but I'm here for you. So as for the question to answer the video, the question you'll need to answer is, do you like smoothies? And if you do, what's your favorite type of smoothie? So I'm going to make sure that you'll have to answer that question in the homework. But other than that, I'm going to put a couple of these up for you guys to work on. Subnetting is really important, and it is a huge part of computing, because once you get this down, we can start using software to build our own networks, and we can actually see if it would work. So again, if you have any questions, please message me on campus. But yeah, other than that, I will see you guys later. Stay healthy.